Okay, this is VHDL, and this is part 2 of listing 1-4. Alright, in 1-4 we basically showed you the difference between instantiating using the VHDL 87 format and versus listing 1.3, which uses the newer VHDL format. Okay, which is I like a lot better. It's a lot cleaner. Okay, let's actually modify this test bench file to not use the 87 format. Okay. Well, if you're not going to use the 87 format, but you're going to use the newer format, then what you can do is you can get rid of that declaration. So you don't need to do this declaration now. So we can take this guy and I can comment it out. All right, so it's gone. And then down here, though, I got to change up this declaration a little bit. I still give it a unit under test. That's fine. I still give it a label, but I have to add that entity keyword. Alright, and then after the entity you got to tell it what workspace it's in, because potentially it could be in another library or another workspace. Then you got to tell it EQ2, but then you also have to give it the architecture name. Okay? Well, what was my architecture name? Well, go back to EQ2, and my architecture name was simply called behavioral. So let's copy that. Go back to my test bench file, and we will put that into here, and then you can start the port map statement on the next line. And that is really it. That's all you need to do. The stuff inside the port map stays the same. Okay, so yeah, so the neat thing about it is you no longer need this declaration, but you need to add a few things, namely the entity keyword, the work, and then the tag on the architecture block. So at this point right here, let me recompile everything. Okay, EQ1 still compiles. I could rerun that guy, the check EQ2, even though it says it hasn't changed. And then I could redo that guy, rerun all on that guy. And now if I have this selected and I say simulate, it should give me the same results. I just changed the way I instantiated those objects. And let's see if we zoom to full view and we open up these guys, and here I've got 0, 0 on both of them. Let's change that to radix to binary, and then change this guy radix to binary. Here I've got 0, 0 and 0, 0. I get an output of 1. This point right here, I change it to 0, 1 and 0. The output goes to 0. Here I've got 0, 1, 0 and a 1, 0. The output goes to 1. Here I have a 1, 0 and a 1, 1. The output goes to 0. They're not equal. Here I have a 1, 1 on both of these guys. Output is 1. And then here I've got a 1, 0 and a 0, 1. Output is 0. Yeah, so it might actually make it cleaner to look at it like this. Yeah, because there I've got 1, 0 on both of those guys. All right. So let's see, what else can we do? We still have plenty of time here. Let's do something else. Yeah, let's come along here and look at our process. Now in our process, we're kind of brute forcing it, and I basically have 4 inputs, 2 on A, 2 on B. So I've got 4 bits, which is 16 possibilities. Maybe we can get a little smarter here. Let's try to do something like this. Let's say 4I in 0, 2, 3. Okay, and then let's see, loop. Okay, and then let's see, I'll do end loop right here. Okay, and then let's put another loop inside there. Let's do 4J in 0, 2, 3 loop, and then we'll do end loop there. Okay, and then inside here, what I'm going to do is I'm going to say TB, test bench B, is going to take on the value of standard logic vector. I'm going to convert it to a standard. I'm going to say to unsigned, and I am going to say J, comma 2 bits. Okay. So J is going to go from 0 to 3, and I can represent that with 2 bits. I'm going to take J, convert it to an unsigned, and then to a standard logic vector, and then assign it to TBB. And then here I am going to wait for 50 nanoseconds. Okay. And then, let's see, down here, let's see, how can I do this? Because then what I need to do up here is I also need to set this guy. I need to set TBA test bench A, and we'll set that to I. So I'm going to set I to 0, and then I'm going to loop through J. 0, 1, 2, 3. Okay, and I want to wait inside here, and then wait, and then I pop out, and then I change A, and then I change B, and I wait. Yeah, let's try that. Let's actually get rid of all this stuff and see if we can just, instead of brute forcing that, let's see if this works. So now I've got a loop in there, and let's go ahead and put in the assert false, and then we'll kind of tab over. We'll report. Just kind of, little message done, and then we'll say severity failure. Yeah, and try that. So now this process basically has a for loop inside. A little for loop repeating. So at this point, let's go back and make sure everything compiles. Let's run that. Okay, EQ1 still successfully compiles. What about EQ2? Let's rerun that guy. That's good. Now what about my test bench file? Let's double click that, and oh, I got some errors here. What kind of errors do I have? Let's see, it says to unsigned. Oh, it's not declared. Yeah, see this function right here, to unsigned. Well, you gotta modify some things to be able to use that. And if you go to the top of your test bench file, that's one of those things we actually took out. And when you need to put that guy back in there, and it's IEEE dot numeric standard and then all. So remember, the library, or bringing in the IEEE library, a library contains packages. Standard Logic 1164 is one of the packages. Numeric Standard is another package. And inside that package, you have all kinds of data types and operator overloads and all kinds of things. We're bringing in all that functionality. So if I bring that library in, and now I try to rerun this guy. Okay, it looks good. Let's go back and just double check everything. EQ1 is compiled, EQ2 is compiled, and then test bench. So at that point, test bench is highlighted. Let's double click simulate behavior and see if I actually enumerate through all 16 possible inputs. And let's see what happens. Hey, I think I do. I think it worked. I think it worked actually, yeah. So let's kind of change this guy to binary. And look what we've got. Yeah, so basically the A is 0, and then B goes from 0, 1, 2, 3, and then I bump up A to 1. B is 0, 1, 2, 3, and then A takes on a value of 2. B takes on 0, 1, 2, 3. A takes on 3, and B takes on 0, 1, 2, 3. And yeah, notice the only time I assert is when they're both 0, 0, or both 0, 1, or both 1, 0, or both 1, 1. Alright, so that's pretty cool. Pretty cool. Yeah, we were actually able to add a little more sophistication to our test bench process by using a for loop. And we basically said I goes from 0 to 3, but then I needs to get converted to a standard logic, but there's no way to convert an integer straight to a standard logic. You have to convert it to an unsigned first, and then an unsigned to a standard logic, and then put it into your test bench variable. And that test bench variable A, of course, in my instantiation, got mapped to the A input on my EQ component. And then, of course, if you go inside EQ2, A got broken up into 2 bits and connected to I0 on the EQ1 component. Alright? Okay, well, I think I'm going to stop there. That was a good one.